Good morning and a very warm welcome to all of you joining us from across the globe. I'm Veena Gowda, your host for today. Thank you for joining us for this webcast on mastering the key elements of cloud-based development for SaaS applications. Let me introduce you to our speakers. We have Jyoti Rangarajan, Principal SaaS Architect at Aspire Systems. She has over 2 decades of expertise and is the architect of an award-winning SaaS development framework, TechFellow, which has won accolades like Gartner Cool Vendor, Microsoft Partner of the Year finalist, SIA Cody finalist. And we also have Chandramouli Parshuraman, Senior Technical Architect at Aspire Systems, focusing primarily on open source, cloud, and mobile technologies. He has over 16 years of experience in the IT industry, managing roles that cover complete software development lifecycle. Chandramouli drives the technology direction for open source and Java teams at Aspire. I welcome both of you.
Good morning.
Good morning, everybody.
Thank you. Before we begin this webinar, there are some house rules on the usage of the BrightTalk portal. If you have questions, kindly write it in the questions section. We will have a Q&A session towards the end of the webinar where we'll answer all your questions. However, if some answers are elaborate or we run out of time, we would get back to you via emails. So do remember to share your email addresses for us to contact you later. Let's get started, and I hand it over to Jyoti.
Good morning, everybody, once again. Gartner has predicted that by 2019, more than 30% of the 100 largest vendors will complete the transition from cloud first to cloud-only model, meaning their investments will be shifting away from on-premise to complete cloud-based services. The evolution of cloud has reached a point where companies are no longer asking why cloud, but instead, why not cloud? Cloud-based software provides important advantages such as IT costs, savings, reduced capital expenditures, enhanced security, and flexible operations. The scalability of cloud software solutions is a key benefit for companies which prefer the flexibility of per user or per month pricing model, which is popular with every cloud vendor. Delivering software solutions through the cloud enables software vendors to reach wider markets, accelerate deployments and development, and also increase customer satisfaction. Let me begin by clarifying the myths around cloud solutions. It's misunderstood by most that cloud solution is just machines which are migrated to cloud. While lift and shift could be the first step in migration, cloud solution is definitely not a replica of a non-cloud architecture with just machines replaced to a cloud environment. We need to adopt the strengths that cloud provides, which includes the infrastructure services, platform services, and the SaaS services for the right scenario to arrive at an efficient architecture. Practically, a cloud architecture looks utterly different from a non-cloud architecture. One of the other common myths about cloud is that it's not secure. This has been proven absurd over a period of time. Once you understand cloud and its features, you will agree that it's definitely much more secure than a non-cloud environment. Just not that, the security controls are very easy to establish and manage in a cloud scenario. Other elements that concerns ISVs are the possibility of cost creep in cloud. Cost creep, though possible in cloud, can be overcome by controls and automations that you can easily put in place. It's also a fact that from scale and efficiency perspective, a cloud-native solution is much more efficient compared to any non-cloud solution. Cloud has entirely transformed the way we look at a SaaS solution, both from technical perspective and operational perspective. Architects are empowered in cloud to make the right choice of technology and decisions that's constrained in a non-cloud environment. If not for cloud, architects need to be extremely cautious about the total cost of ownership of the architectural solution, the maintenance costs associated with it, procurement delays, etc., etc. Another important aspect is that technology keeps changing over time. What's relevant today need not be relevant tomorrow. In a non-cloud scenario, the architect is literally married to the first choice made because of the investment made on the license, hardware for that choice, etc. In cloud, new technology can be adopted instantly. For example, if a use case demands a use of a NoSQL, you can adopt that without waiting for the entire setup to be in place or worry about the loads of RDBMS license that's purchased. Moreover, a large amount of architect's time is also spent on the physical architecture of the software rather than the software architecture in a non-cloud scenario. Elasticity and pay as you go helps architects for high scale and spikes in a very cost-effective manner. From an operations perspective, again, cloud removes significantly the maintenance overhead, especially if you adopt the past-related services such as storage service, maintenance, VR, replication are all completely handheld handled by the cloud provider. This saves a whole lot of maintenance costs. Out-of-the-box monitoring solutions available in cloud provider again facilitates the automation of monitoring and its action which eliminates the need of manual monitoring. We have seen cases where more than 100 plus servers are managed by 2 DevOps, which is out of question in a non-cloud environment. Other advantage is the speed with which you can start using any technology or service. Procurement delays and setup time can be entirely eliminated, and provisioning is usually as easy as click of a button. There are 4 mandatory technical characteristics for any SaaS application: security, agility, availability, and scalability. We are going to analyze in depth how one could take care of all these aspects seamlessly and let SaaS providers concentrate solely on their business functionality. Security as defined by the AIC triad model is a combination of confidentiality, which is the privacy of data, integrity, which is the accuracy and trustworthiness of data, plus operations and availability, which is the obtainability of the data. In order to achieve this, combination of data at transit security, data at rest security, and proper access control list has to be adopted. Let's look at what cloud offers out of the box to achieve this and how easy it is to establish these controls. For purpose of this webinar, I'm going to be referring to AWS and Azure, which are the leading providers of cloud. The same holds good to other cloud providers as well. Cloud supports configuration of multiple layers of network security. You will be able to set up a virtual network and a subnetwork in cloud that more or less acts like an extension of your on-premise with the required IP address range. You would also be able to restrict access to services based on granular access control rules and policies. Most of the cloud providers offer web application firewall services which can be used at least to prevent against web application security threats. All the services that are provided in cloud are protected by secure connections. All the storage services such as database as a service, blob service, NoSQL service, For example, S3 in AWS, Azure SQL Database and Cosmos in Azure have the ability to encrypt data storage. Most of the cloud providers also provide identity and access management services, which enable to have a strong access control policy for services. This also offers features such as single sign-on and group-based access restrictions that can be easily integrated with your product. Out-of-the-box monitoring services offer detailed threat detection capabilities that can be utilized at ease. For example, AWS offers Trust Advisor, which provides a complete view of threats of all the services. AWS provides Security Center service, which is similar to the Trust Advisor. Key management service is again a very important service and widely adopted service in cloud. For SaaS applications, to architect, we end up needing multiple secrets such as connection strings, certificates, etc., etc. KMS service or a key management service allows to store these secrets confidentially. Azure offering, which is a key vault, and AWS offering KMS are all examples of the service. This is a summary of the points that we saw now. This image is a view of security monitoring available in AWS. You could see that you get pretty dashboards on the threads, and it's available across the services in a single view. This is a similar view from Azure, which again provides a detailed analysis of threats across the services. Moving on to the next topic, which is agility. Agility is one of the main advantages in moving to cloud. SaaS models, as you all know, need extreme agility. The process needs to support frequent, efficient releases. As earlier said, new technologies need to be adopted faster and corrections have to be made instantly. In order to achieve all these, automation is key. Cloud enables automation at ease. The major driver for these are three factors: ability to create the entire infrastructure and services using version control mechanism. The whole service and release management being available as just REST APIs makes us look at the entire infrastructure element as same as software features. This is one of the main reasons for sophistication and the success of cloud. Critical feature available in major cloud providers is what we call as IaaC, which stands for Infrastructure as a Code. Now, infrastructure as a code is the ability to create an entire environment, including the dependency between the resources, using configurations such as JSON file. The diagram that you're seeing here is a sample of such a config. Apart from production capabilities, cloud is also becoming very popular for integration and test environments. Cloud providers offer services which allows an administrator to set up and control access to environments that then development team and QA team can self-provision as they need. The usage of these environments can be controlled further by strong policies. AWS Service Catalog and Azure DevTest Lab are all examples of such service. We have hugely implemented this for our customers widely in an agile feature-based development. Once the feature team finishes the development within a sprint, they provision an environment on demand, test the feature, and hand it over to testing. We have noticed by using this, It improves the quality of the software more and decreases bugs that are found in the QA. Most of the cloud providers also provide an entire set of CI/CD capability, which makes the application lifecycle management pretty easy. The image here shows the different CI/CD capabilities which are available in AWS. The other factor which is obvious is the cost control that we get. You only pay as per your business demand. You send services automatically when there is a huge surge and bring it down as the surge subsides. This provides a greater control of cost. We can also put in place auto shutdown and scale up mechanism wherever possible. This allows one to use multiple services as per the recommended practice and at the same time not increase the cost. The image that you're seeing here is an example of a mechanism where you can auto scale up and auto scale in based on various criteria. Moving to the next, out-of-the-box monitoring solutions allow great in-depth detail analysis of both infrastructure and application. The image that you are seeing here is a view of App Insight, which is the application-centric monitoring service that's ready-made available in Azure. It's pretty easy to integrate with this service, and then you get a view of entire activity that's happening in your application. Similarly, you have an offering from AWS as well, and this image shows the infrastructure-centric monitoring available in AWS. The other two aspects of SaaS, as we discussed, are availability and scalability. To throw more light on it, I'll hand it over to Chandramouli. Over to you, Chandramouli.
Thank you, Jyoti. Availability is another key mandate for SaaS application nowadays. Being able to access the application centrally and in a secured manner and achieving SLAs which are pretty close to 4 nines or 5 nines, that is the goal of all SaaS applications. And cloud inherently provides lots of features to achieve this. Automatic failover is handled by all the platform services, and these platform services, as we just discussed, promise 999 or 49 or even 59 SLAs in many cases. As architects, we just need to configure the right options provided by these services. As part of availability, automatic failover is one of the most important things that we could take care of through cloud solutions. So whenever a cloud instance of any type is configured, you have an option to choose an availability zone. For example, US East, US West, London, Tokyo, and so on, which could be determined based on your needs. For example, the proximity of users in the geography, which is pretty close to your application. Either within the given geographical zone or even across multiple zones, it is now far easier to set up an infrastructure on the cloud in order to handle failover scenarios. Different strategies have to be followed while setting them up based on your priorities on various deployment parameters like the size of the application, the frequency of deployment, and even the cost of deployment, etc. A suitable strategy has to be chosen accordingly. For example, having a clone environment fully in another availability zone as a standby might be cheaper, but it doesn't keep up to date with the latest changes inside the storage. But having the storage completely replicated and in sync across different zones could also be set up very easily on cloud, but that incurs additional cost too. So choosing the right deployment architecture with the help of a cloud architect is very essential to the success of your product. Currently, all major cloud providers have presence across multiple availability zones, including US East, Central, and West, all major cities in Europe and Asia Pacific, and in some cases across South America too. This map is an indicative list of the availability zones of three major cloud providers: AWS, Azure, and Google Cloud Platform. Major new centers are being added very frequently to cater to the growing demands. That brings us to the topic of geo-redundant storage. This is the ability of cloud providers to replicate and store your data in a geographical region that's hundreds of thousands of miles away from your primary region. AWS offers cross-regional replication as part of its S3 storage offering. Azure has geo-redundant storage as a feature for its storage offering, which could include blob or file or even queue-based storage. The next important technical aspect that we have to look into is scalability. Scalability is a core requirement in any SaaS application, and we recognize that SaaS is a volume game. The load on any SaaS application is going to be exponential compared to a non-premise solution. So it is important to architect all the layers of the application with scalability in mind. There are patterns that help in achieving high scale in the application layer, such as microservices or serverless computing. Cloud simplifies building these patterns pretty easily. In addition to that, it is important to design the data storage layer in a way that it scales well. There are various factors that cloud offers to simplify this. There are two techniques that you could adopt to scale. One is scale up and then the other one is scale out. Scale up is increasing the resources such as CPU and memory. Scale out is adding more nodes to an existing cluster and then balancing them. But there is another aspect to scale, which is elasticity, which is a specialization of cloud, I would say. So that is a key aspect of cloud that makes it superior to non-cloud solutions. Elasticity enables scale up, scale out, and scale in based on the parameters such as load, etc. If you consider scale up and scale out as incremental or a unidirectional change, elasticity provides you the ability to scale in or scale down, which means you could reduce the resource usage, which helps you in achieving better cost efficiency also. So from cloud scalability components perspective, we will look at four major areas: Autoscale, serverless computing, infinite geographically distributed storage, and big data computing. Autoscale is the ability to automatically scale out or scale in based on the parameters such as load, schedule, and various other such parameters. Let us look at what cloud offers out of the box to achieve scalability at different layers. When you're using infrastructure as a service or application services, you can configure Autoscale. This enables the scale out of the instances based on the criteria of CPU usage or memory usage. And similarly, we can set up criteria for scale in also. From the picture that you see here, you could notice that we are specifying CPU as the parameter for Autoscale. The size of the instance here is a small 1-core 1.75 GB instance. The number of instances that you have in this Autoscale group is going up to 5 instances, and then the target CPU that you want to cover, the moment you want to trigger an Autoscale here, is up to 70%, somewhere between 40 and 70%. The next aspect is serverless computing. Serverless computing has become a success trend in the recent past. That is mainly because of the effortlessness and then the cost efficiency that it presents. It works by submitting the code that needs to be invoked in a certain unit. The underlying server and the infrastructure that is used to run the code is completely abstracted from us. The factor that you are charged only for the time the code takes to execute, that results in extreme cost efficiency. We could, in a way, compare serverless computing to the usability paradigm of Macintosh, where in Mac you generally see that you do not exactly see drive names like C:, or D:, when you want to access your files, media files or any other such files. But Mac provides categories like applications, documents, videos and audio, and then it becomes very easy for the end user to understand such a paradigm. In a very similar manner, serverless computing provides you the ability to just specify what function that you want to run based on a specific trigger. But then how the server is provisioned, what kind of OS and what kind of environment that it has to be provisioned on, and what are the availability zones that you have to worry about. These are some of the things that the serverless computing completely abstracts away. And here are some of the use cases for using serverless computing. IoT data processing, infrequent tasks such as customer provisioning that you would typically do in a SaaS-based application, tasks driven by queues such as order processing, inventory management, webhook processing that is typical in any REST-based scenarios. Coming to the storage services within the scalability, cloud offers multiple choices for data stores depending on the type of storage, such as blobs, relational data, NoSQL data. And RDBMS stores can be instantly scaled up or scaled in. Blob, NoSQL storage, they also provide infinite scale out of the box. So what you see here are some of the examples of storage services provided by AWS and Azure. AWS provides EBS, S3, Glacier, and then storage gateway. And from Azure, you have SQL database, you have table storage, you have blob storage, and you also have database MySQL, Postgres as infrastructure as a service. The next aspect that we are looking at is the big data computing. There are also managed big data services offerings and HPC available in cloud. The complex part of setting them up and then managing the big data stack is entirely eradicated now. You can spin off instances of entire big data stack in minutes rather than days and then start consuming it from the day one. So the examples that you see in the current slide, they are from Azure. Some of the services that you see are data lake store, SQL data warehouse, and you also have various tools related to machine learning, data lake analytics, and then HD Insight as part of your machine learning and analytics. And these are some of the examples of services from AWS for big data. You have Amazon EMR, you have S3, you have Amazon Redshift. All these can work in conjunction with the services like Amazon RDS or tools like Cassandra, and then they are all orchestrated using AWS data pipeline. Now, over to Veena to further take this.
Thanks, Chandramouli, and we do have some poll questions, so I would request the participants also to answer the poll questions. They do come up below your screen, just below the presenting screen. There's a second menu option, which is just next to ask a question, which is vote. So if you click on that, you can see the different questions that we have posted, for which you could answer or choose whatever you prefer. So I request you to also participate in these poll questions. It will help us to provide much better answers, as well as have interesting webinar topics coming forth. I hand it over back to Jyoti.
Thank you, Veena. So far we looked into the various aspects that are important for a SaaS solution from a cloud perspective. Now we are going to discuss about two customer success stories today who adopted cloud and were able to run their solutions more effectively. The first customer is a leading document management software provider. This customer was on an on-premise model and wanted to move to a multi-tenant SaaS model. In order to do that, they were looking for a platform which would help them scale efficiently and also accelerate their movement to a SaaS model. We worked with this customer and built a scalable and secure solution using the PaaS services of Azure. Azure's storage service helped in achieving the huge scale that their business demanded, and the shared access security option available in Azure storage service, which is the Azure Blob storage, made it very easy to share the documents to various customers and collaborate. The solution post the entire replatforming and on Azure supports a high concurrency and a very high volume of documents and workflows in a very reasonable price. The different services that were used from Azure are the blob storage for storing the files effectively and securely, the PaaS service, which is the app service including the API app and the web app to easily run the web application and the API layer, Azure Functions for processing events and webhooks. Azure Function is an example of serverless computing in Azure. Azure Batch for document processing. Azure Batch is a high-performance cluster that's available in Azure. Azure SQL Database, which is the PaaS version of the SQL Server for data storage. And Azure ADB2C, which is the identity and access management solution available on Azure. So all of these services were used in conjunction to provide a scalable and secure solution. The second customer is a leading insurance provider. They moved from an on-premise solution to a hosted SaaS single-tenant solution. You will know that the time taken to onboard a customer is huge in a hosted solution. We developed here an architecture for the customer that automates the entire environment provisioning of their customers. We collaborated with the client and helped them in building this tailored deployment model in AWS that helped them support their customers better and onboard them much more efficiently. The technology stack that was used for the solution was Java, and a microservice-based architecture was deployed. From a cloud service perspective, CloudFormation and EC2 were the main services used, and Service Catalog was utilized to provide customers a staging environment that they could themselves provision, test, and then move to live seamlessly. Notifications were sent using SNS and SES, which is the simple email service and notification services of Amazon. And the entire process was automated and the development pipeline was automated, which utilized code commit, code build, and code pipeline services of AWS. The highlight of the solution was that the automated deployment The new customer was able to be onboarded into the system pretty easy. The effort required by the support team was significantly reduced, and clients were managing their own sandbox environments. The solution was built as a pseudo microservice that's orchestrated in a scalable model. Some of the services had multiple implementations that can be done in runtime as well. Now that we have seen two customer success stories, we wanted to pick a use case that will explain the strength of a cloud. This use case that we are going to see is for one of a financial products. This product has around 1,000 plus customers, and each customer has more than 5,000 users. The concurrency that's expected at any point in time on the system is 1,000 plus. Users can perform some actions and generate their organization's financial report. Now, this report can range from 200 to 500 PDFs. You can imagine the load that's going to bring into the system at peak concurrency. This use case would have needed a lot of work and cost if it was done in a non-cloud scenario. Now, let's take a look at how it's handled in cloud. In this case, we have used Azure. Once a user performs the action of report generation, a message is sent to a Azure Service Bus queue. A web job picks it up, and then a batch is run, an Azure batch is run, whose number of jobs and resources to process it is dynamically calculated and allocated as per the number of reports that can be run in parallel. As I mentioned earlier, Azure Batch is the high-performance, high-parallel cluster available in Azure. Once the Azure Batch processes the report, it is finally zipped and stored in Azure Blob Storage. Users can then download the zipped reports from Azure Blob via a URL, and they could also share it using a SAS token or a shared access token. With this architecture, we are able to scale out and achieve an economy at a very reasonable price. So, from the discussion, you would have understood that cloud has already become the de facto choice of SaaS vendors. The cloud providers are adding much more services day to day to make solutions easier and faster. And if you have not made the move to cloud, it is late than never, and you can make the move immediately. Thanks a lot, and over to you, Veena.
Thanks, Jyoti. So before I move on to the Q&A section, I would like to remind once again, please do participate in the poll questions, because that really helps us in bringing out more such interesting webinars. And moving ahead, I would like to introduce you to Aspire Systems, a global technology services firm serving as a trusted technology partner for our customers. We work with some of the world's most innovative enterprises and independent software vendors, helping them leverage technology and outsourcing in our specific areas of expertise. We have technology expertise around software engineering, digital services, testing, and infrastructure and application support. Our targeted industry focus areas are retail, banking and financial services, and insurance. Aspire has extended its global presence across US, UK, Singapore, Benelux, Middle East, and India. Now, let us take some of the questions posted by our audience. So, yes, we have the first one, which is, does adopting cloud increase my cost? Jyoti, would you like to take this up and answer it for us?
Yes. So it is, as I explained, a common myth that moving to cloud usually increases the cost. It's definitely not the case. It's in fact the other way around. if you place proper controls and adopt what cloud provides you, especially the agility and the automation of it, you can easily bring down the cost to a great extent, and it will prove out to be much more cheaper than your non-cloud environments. Things like auto shutdown, and then the scale-in policies that you can adopt allows you to increase the resource only when your business demands, and otherwise you can run it in a bare minimal cost. So that's the main advantage of cloud, and if you properly architect it, the cost surge wouldn't be an issue at all.
Thanks, Jyoti. We do have another question, which is it a safe strategy to choose more than one cloud vendor? So, Chandramouli, would you answer this please for us?
Sure. We would say that to choose more than one cloud vendor might not be a good strategy. You start with just one vendor and then proceed, particularly from an ISV perspective. It helps you actually make better use of cloud and then achieve the efficiencies that it provides. Otherwise, I think it defeats the whole purpose. Whereas for an enterprise, it could be a different story, where if you have multiple systems that are internal to you, and then you would like to choose something else or choose a different vendor based on the need, that is a different story. But from ISV perspective, at least, we would definitely recommend going with just one cloud vendor.
Thanks, Chandramouli. That's great. And let me just once again run you through our cloud expertise. We have more than 80 plus SaaS products built from the ground up. We have 6,500 product releases till date and 1,400 strong team with product development expertise. So that's quite a lot of cloud expertise that we have, and I hope our audience would come back to us for some feedback or any support that we could provide. Now, if you have any further questions, you can always write to us. We have our email address given at the end of the webinar. Yes, in the Q&A section slide. So we will wait for another 15-30 seconds for some more questions. Well, that brings us to the end of the webinar. We thank Chandramouli and Jyoti for sparing the time and putting up such a great presentation on SaaS architecture and how things could be improved, and and the myths that are broken today. I'm sure we have learned a lot from this. We thank you all on behalf of Aspire Systems for joining us today. Have a great day ahead and a wonderful weekend, which is just around the corner.
Thank you.
Thank you.